All right. Hey, everybody. I got a microphone now, so you'll be able to hear me. That's great. Not super high tech because I got a cord. So if I trip, well, lucky for you, some comic relief. All right. So now we're getting into the meat of Math 175, sequences and series. All right, so let's do sigma sums. All right, let's do an example here. All right, so let's start with something like this. N equals 1 to 3 n cubed. All right, make sure you read the notes and learning goals. Really great. They really give a lot of good information there. I'm going to expand on those now. So I don't see any reason for me to just reread the notes and learning goals. It's not going to help you get your homework done. So I'm just going to do a couple examples. I guess I'll do an example now, and then I'll do another video with another example. I'll do a few examples for you guys. Okay. Anyway, all right. So what is this information or this notation? Okay, this is like you've seen before. This is an. But this is saying add them all up. Okay. So this is a sigma, capital sigma, saying add them all up. Starting at 1, go to 3. Okay, so starting at 1, stop at 3. But you got to include 3. So you got 1 cubed plus 2 cubed plus 3 cubed. Okay, so that's what that notation means. Similarly, let's see, let's do another one. Let's say, let's start at 3 cubed plus 4 cubed plus 5 cubed plus 6 cubed. Okay, so we're looking at that. This is a sum. Like, see, we're adding all these things up. So we got a sum. Let's see, we start. Let's see, what's the formula first? The formula we're using is n cubed. And we start at 3 and we end at 6. So n equals 3 for our start, and 6 is our stop. All right, so that's how that notation works. Okay, so now what we want to do is we want to, so let me move this up here so I got a little more room. First, you got 1, 3, n cubed. This is 1 cubed plus 2 cubed plus 3 cubed. Okay. All right. So what we want to do is we want to draw rectangles, the rectangles that this sum represents. This is very similar to approximating integrals using the Riemann sum. Okay. All right, so first thing, let's see, let's make a little table. We got n cubed. And let's see, we're starting at 1 and we're going to 3. So we got 1, 2, 3. 1 cubed we know is 1, 2 cubed is 8, and 3 cubed, let's see, that's 27. All right. Okay, now I'm not going to be able to do this entirely to scale here, okay? Because as you can see, at 3 we got to go all the way up to 27. If I did it exactly to scale with this scale that I have drawn here, then I would be like way up above the board. That's not going to work, right? So it's not going to be entirely to scale on the y-axis, but it'll hit home the point, and that's the most important part. Okay, so let's see, at 1 we go up to 1. Okay, so we could look at, okay, so we have at 1, we're at 1 there. At 2, we're at 8. Let's say 8 is about, let's Let me move it down a little bit. Let's say at 2, we're at 8. And at 3, we're at 27. Okay. Now, each of these dots, that's the sequence, right? That's the graph of the sequence an equals n cubed for n equals 1, 2, and 3. This is talked about on page 2, at the top of page 2, bullet point 2 in the notes and learning goals. So see that there. This is for a different example. Okay. Now, with the sum to add to represent the sum, right? This doesn't represent the sum. This represents these 3 dots. This represents an. An equals n cubed for n equals 1, n equals 2, and n equals 3. If we want to represent the sum, we need rectangles because we need to be able to add something up, right? Okay, so something like that. Oh, that doesn't look quite right, does it? Like that. Okay. Okay, so this area here, right, this is what this sum represents. All right, so we can draw this in 2 different ways. Another thing that they mention in the notes and learning goals, let me draw it the other way. Okay, do 1, 2, 3, 4. This way corresponds to how you approximated with right endpoints. 1, 8, 7. Okay, still the sequence dots are going to be the same. No change there. Oops, that doesn't look right, does it? Okay, let me see. Like that, and like that. Okay. Boy, this is not looking good, huh? I gotta fix this a little bit here. Jeez, what a disaster. All right, so same thing, either way. Right, so think about this, right? Whether you have a block, a rectangle of width 1 and height 1 written here, this rectangle of width 1 and height 8, width 1, height 27, whether you have it shifted here or shifted over, still the same, represents the same sum, the same amount, right? So I'm going to put equal, right? This is equal to that.